In this video, I will work on the last 4 of the practice hypothesis test problems as a way of giving you some additional information, or maybe encouraging you to continue to work on them, hopefully answer some additional questions. Let's start with the consumer behavior problem, and it states that as part of a survey to determine the extent of required in-cabin storage capacity, a researcher needs to test the null that the average weight per person is 12 pounds, and that's the carry-on baggage, is 12 pounds, versus the alternative hypothesis that the average weight is not 12 pounds. Notice that it has a straight equality. In other words, it's not a greater than or a less than. So our null will be that average weight, mu, is equal to 12 pounds. And the alternative is that it is not equal to 12 pounds. So we look through the rest of the information, see nothing about the population variance, and therefore we're going to need to use the univariate t-test where the population variance is unknown. So let's start by collecting what we do know and have been given as information. The hypothesized mean is 12 pounds, so we'll input 12. The standard deviation, we're told, is 7.8. The sample mean was 14.6, so let's input that number. And we're told the sample size is 144 passengers, 144, and that the alpha in this case is 0.05, therefore the level of significance, 1 minus, is 0.95. And so now we have our information and our results, and we can then test the hypothesis. We've laid out all the initial information. We have a test statistic, 3.6818. I double check my numbers up here. Sample size 144, not 122. And we see that the test statistic is 4. And since it is straight equality, remember it was average weight is equal to 12 pounds. It's a two-tailed test. We see that the critical value is 1.9767, which is less than our test statistic. So our test statistic is larger. Since it is larger, we would reject the null. A second test or a second check would be to compare the p-value, in this case 0.0001, to alpha. It is also less than, therefore we reject the null and state that the null is not true, that the average weight is not 12 pounds. And therefore some result from that would happen. Moving on, the second problem has to do with the real estate. And in this one, the statement or the problem says, according to the Japanese National Land Agency, average land prices in central Tokyo soared 49% in the first 6 months of 1995. An international real estate investment company wants to test this claim against the alternative that the average price did not rise by 49% at a 0.01 level of significance. Now, the fact that there are percentages here might lead you to believe that we're dealing with a proportion problem. However, when I look through it, I notice that I see the average prices, I see a standard deviation, and I also see another average price. And so even though the data happens to be percentage, it is in fact a continuous data problem because that percentage can exist in an infinite number of values. So we don't see anything here regarding a population parameter. So again, we're using a t-test where the population variance is unknown. So let's clear out the information from the previous problem so that we can input new information. Okay, the claim is that 49% we will convert everything to decimals. So 0.49 is the hypothesized population mean. we see that the standard deviation is 14%, so we'll input a 0.14 there. The sample mean was 38%, so 0.38. Sample size, 18 parcels, 18. We're looking at a alpha of 0.01, so therefore our level of significance 0.99. And we have what we need to know. All right. Now in this case, it's a two-tailed test, straight equality. We have a negative test statistic t minus 3.3335, and we see that the critical value is 2.8982, which of course this is since it's two-tailed, this is a plus or minus, and that value is less than our 3.335, and we see that the p-value 0.0039 is less than 0.01. So in both cases we would reject the null, and the null was that prices soared by 49%, and the resulting conclusion is that they did not. The finance problem next, we worked in class. This is a test of proportions. It has percentages, but it also has accounts, number of accounts, 210 accounts and 130 accounts. So this finance problem happens to be a test of proportions. Let me run through it quickly. The statement is that one of the tests that 70% of all the investors are American. So there's no direction indicated, no less than or greater than. So we'll use that. Let me move to, on our spreadsheet over here, move to a one sample test of proportions. And we have all of our data given to us. Sample size in this case we said was total sample 210 parcels. Okay, 210 parcels. Number of successes. Successes is defined as whatever concept we're interested in this case American owned accounts, and we have 130 of those, so 130 here. Estimated population proportion, that's the original hypothesized value, in this case 70%. We'll calculate or convert that into a decimal. And last, alpha 0.05, therefore 0.95 is our level of significance. And what do we see? We have a negative t-score of minus 2.56. Again, because we have no direction, it's a two-tailed test. Our critical value is a plus or minus 1.96. That value is less than the z-score, so we would reject the null there. Second, the p-value 0.0105 is less than 0.05. We would reject the null. Keep in mind the null was that the proportion was equal to 70%. In this case we reject that because the actual proportion right here, it calculates it at 61.9%. So we reject the null and declare that the statement 70% of all foreign investors are American, that statement is not true. Last is the product safety, and in this case looking at the effectiveness of airbags, found that in 821 crashes of cars that had airbags, 46 of the crashes resulted in the drivers being hospitalized. And so they want us to test the claim that the rate is lower than the 7.8 of car crashes in which there are no airbags but rather automatic safety belts. So here we have our a direction, because it's telling us that the proportion is less than 7.8. So therefore, because we have to have an equality in the null, we're going to reverse the sign to create our null hypothesis. And so our null hypothesis is that the proportion is greater than or equal to 7.8%. So we'll again use our one sample test of proportions. Let me clear out the old information and we'll input the new. Okay, the sample size in this case, a total of 821. So 821. Okay, the number of successes, in this case successes, is defined as hospitalization of drivers. That's what we're interested in. That's what we're calling a success. So out of this number, 46 incidents or crashes caused the driver to be hospitalized. The estimated proportion we see is 7.8%. We're going to convert that to a decimal, 0.78. And level of significance, we want to look at alpha as a 0.01. Therefore, we're going to use a 0.99 for our value. Now we're ready to compare. We see that it is it's a one direction test because it has a rate in here, a lower than, a direction. Because of the way we've laid out the null, the rejection region is in the negative tail. So now we're ready to look at it. The z-score is a negative 2.347. The critical value is a negative 2.326. So it's just barely larger, but it is indeed larger. So we would reject the null. The other aspect is that the p-value of 0.0095 is in fact less than 0.01. So based on these two tests, we reject the null. And the null is that the proportion is greater than or equal to 7%, and that is not true. The alternative is that the proportion is less than 7.8%, which is probably what the founders or the funders of this study were interested in saying, is that the rate airbags reduce the hospitalization rate below or lower than 7.8%. Hopefully this will help as you work through these particular problems.